So the next lesson we'll be revising is carbon and its compounds. As the name suggests, carbon and its compounds. So basically in this chapter, we shall go through all of those compounds which consist of mainly carbon bonded to some kind of element. So even before coming to the compounds, let us just go through what carbon atom is. Now, carbon, atomic number being 6, has 2 electrons in the first shell and 4 electrons in the second shell. Now, in order to become stable, it needs 4 more electrons. See, to satisfy octet rule, it has to have 4 more electrons, that it has to accept 4 electrons. In order to satisfy duplet rule, it has to give away 4 electrons. So this tendency of the carbon either to give away 4 electrons or gain 2 electrons is what is called as the tetravalency nature of carbon, which is the main reason for billions and billions compounds that we see today in organic chemistry. So it is nothing but organic compounds. So organic compounds are those basically which have mainly carbon in the compound, right? Okay, next. So when it comes to this, we'll also have to discuss something called as covalent bond. Now what is covalent bond? A covalent bond is a type of bond which exists between atoms where there is mutual sharing of electrons. So what do I mean by mutual sharing of electrons? We will discuss that with an example. Let us take a hydrogen atom. So hydrogen atom has atomic number 1. So the first shell will have 1 electron. Now we also have something called as hydrogen molecule. Now atom is different from molecule. So molecule, when I say hydrogen molecule, it has 2 hydrogen atoms. So 2 hydrogen atoms combine to form a hydrogen molecule. Now let us see how a hydrogen molecule forms. Now as I said, hydrogen atom having atomic number 1 needs 1 more electron to become stable so that it can satisfy the duplet rule. So now what happens, this hydrogen having 1 electron combines with another hydrogen having 1 more electron, thus forming a hydrogen molecule. Now this hydrogen needs 1 more electron. So what would you say? Okay, let me share your electron. So what happens? This hydrogen will share the electron of this hydrogen. Thus it has 2 electrons for itself, thus becoming stable. Now how about this hydrogen? What happens? This hydrogen will say, okay, let me share your electron. So what it does? It will form a bond like this. So what is happening here? There is mutual sharing of the electron happening. So this kind of compounds where there is mutual sharing of electrons, they are referred to as your covalent bond. Now this is a single covalent bond. Let us come to an example of nitrogen molecule. Okay, so again I have written nitrogen molecule. This is a nitrogen atom. Now the atomic number of nitrogen is 7. So to write off your diagram, how would I write? You have the nucleus here, right? And then you have your 2 electrons. And then atomic number 7. So 2, 5, right? 5 plus 2 is 7. So how many more electrons it needs to satisfy the octet rule? It is 3. I'm saying there is N2 molecule. So how does N2 molecule happen? So you have your nitrogen here, right? And this needs 3 more, right? So what I'll do, I'll write the electrons of the outermost shell. So 1, 2, 3, 4, 5. Right? This is 1 N is done here. I'll take another N here, right? Another N. 1, 2, 3, 4, 5. So how many it needs? How many electrons this needs? It needs 3 more. So what it is going to do? It is going to take the 3 electrons of the neighboring nitrogen atom. Now if you can see, what is the number of electrons now? 1, 2, 3, 4, 5, 6, 7, 8. Which means what? This is stabilized. Now when coming to this nitrogen, what this will do? Again this will take the 3 electrons from the neighboring nitrogen atom. Thus 1, 2, 3, 4, 5, 6, 7, 8. Now this is also becoming stable. Now what you observe here? There are 3 pairs of electrons getting shared. So this I refer to as a triply covalent bond. This is single and covalent bond. This is a triply covalent bond. An example for your doubly covalent bond would be your oxygen molecule. Okay. So that is about your covalent bond. So covalent bond is nothing but mutual sharing of electron which forms the covalent bond. Now, so as I told you what organic compounds are mainly those have carbon and hydrogen in them. You could also have other elements, but mainly they have carbon and hydrogen. Now, your organic compounds can be classified into saturated and unsaturated depending upon the kind of bond. Now, saturated organic compounds or saturated compounds are simply those which have single bonded between the atoms, whereas your unsaturated compounds are those which have double or triple bond between the atoms. So very simple example I could give is CH4. Let us take carbon and hydrogen, methane, CH4. So you have a C, H, H, H and H. If you see, you have single bonded everywhere. So I refer to as a saturated compound. So saturated compounds are those class of organic compounds which have a single bonded, whereas unsaturated compounds are those which can either be double bonded or triple bonded. Now, depending upon the number of carbon atoms, I said the organic compounds are basically those which have carbon and hydrogen. Now, depending upon the number of carbon atoms, I can have a class of compounds which are, which I can name them as methane, ethane, propane, butane, pentane and hexane depending upon the number of carbon atoms. Now, so for methane, carbon will be 1. So it is CH4. Now, when it comes to ethane, it will have C2, propane, C3, butane, pentane, hexane and so on. So depending upon the number of carbon atoms, you have your methane, ethane, propane and butane. So now you will ask me, why is that only 4 hydrogens are bonded to the carbon and why not 5? Now that is a very interesting question. So that I'll explain with a diagram. Now as I told you, carbon has valency of 4. Now it needs 4 more electrons to satisfy the octet rule. So what happens when I'm saying there is molecule of a methane formed, which means there are 4 hydrogens. Now hydrogen also needs 1 electron because hydrogen atomic number is 1. So it also needs 1 more electron to satisfy. So what will happen? I'll just use different signs, different symbols to represent the electrons. Now what happens? This hydrogen needs 1. So it will say, okay, you give me your electron to the carbon. So what is happening? Now this hydrogen is stabilized because it has 2 to satisfy duplicate rule. Similarly, this forms. Similarly, this hydrogen takes from the carbon. This hydrogen already has 1, it will take 1. And hence if you see, all of the hydrogens stabilized, duplicate rule satisfied. Now carbon needs 4 more. So what it is going to do? It will take 1 electron from each of the hydrogen. Thus, 1, 2, 3, 4, 5, 6, 7, 8, thus becoming a stable. So this is how your methane, the first class of organic compound is a methane, and that is the formation of a methane. You can, same way, you can explain the formation of ethane, propane, butane, pentane, hexane, so on, using the same concept of sharing the electrons. If you see here, all of these are covalently bonded atoms. So mainly, your organic compounds consist of a covalent bond, various mutual sharing of electrons. So this is nothing but the classification or a class of compounds you have depending upon the number of carbon atoms. Now, you have also something called as functional groups. Functional groups are those which act as a substituent. So I told you, carbon and hydrogen are very important, must and should for an organic compound. You can also have these, chlorine, bromine, alcohol, all of these acting as a substituent or attached to the carbon atom, which are called as a functional group. So in your syllabus, let us not go in depth. In your syllabus, we have, I think, around 5 functional groups. What are those? You have your halo. Halo matlab nothing but halogens. So halogens are nothing but chlorine, fluorine, fluorine and iodine. You have alcohol, which is nothing but OH. Aldehyde, C double bond OH. Ketone is nothing but C double bond O, and carboxylic acid is C double bond O and OH. So you have to make sure you just write the functional groups 2 to 3 times just to remember the structures. Okay. Now, homologous series. Now I said depending upon the number of carbon atom, C1, C2, C3, you have methane, ethane, propane. So depending on number of carbon atoms, you have different class of compounds. Now homologous series is nothing but the series of compounds in which the same functional groups substitute for hydrogen in a carbon chain. What is happening here? You have CH4, right? I have already shown you how CH4 is. I'll show it again. So you have CH4. Correct. Now what does the definition say? series of compounds which the same functional group substitutes for hydrogen. What is the functional group here? Functional group is just CH4 only. So what is homologous series? A hydrogen gets replaced by the same functional group. Now if you see C2, 1, 2, 3, 4, 5, 6. If you observe CH4, right, I'll repeat again. So you have a CH4, correct? Now I'm saying CH4 and C2H6 form a homologous series, which means what? The hydrogen gets substituted by the same functional group, which means what? Should have a same function group. So what is it? C1, C2. So C2, 1, 2, 3, 4, 5, 6. So you have your C2H6. So CH4 and C2H6 are your class of homologous series. So homologous series are a series of compounds in which the same function group substitutes for the hydrogen in the carbon chain. Next, this is a very, very important topic that you will learn till your 12th. Probably if you do your BSc also, you will still end up doing all of the nomenclature. So it is a very crucial thing that is, that needs a little bit of focus. Now, nomenclature is nothing but because I told you there are millions and billions of compounds, every compound is unique. So even if I replace one hydrogen here with Cl and this hydrogen with, suppose, say Br, okay, this is a entirely different compound. If I just write H here, it is a entirely different compound. Even if I change the position of H and write here, it becomes a new compound. So this is very, very crucial that we follow a set of rules called as the IUPAC nomenclature, which gives us a set of rules for naming your organic compounds. Now you have a very, very basic rules for naming the organic compounds. So the first step is for you to identify the number of carbon atoms. Suppose I have given you this compound. Okay, let us take an example, and I'll try to explain the nomenclature or the rules taking an example. So what is the first step they asked us to do? You have to identify the number of carbon atoms. So taking this example 1. So how many carbon atoms are there? There's 1, 2, and 3. Right? Now, first rule I've counted the number of carbon atoms. And the second rule is identify the functional group. Now, if you see here, you see OH here, which is the alcohol group, which is the functional group, right? So you have to, if there is a functional group, suppose there is just H here, there is no functional group, okay? Now, suppose you have, in this example, you have a functional group, you have to identify what functional group it is. In this case, OH means it is alcohol group. Now, because alcohol group, the functional group is there, you have to start numbering the carbon atoms in such a way that the carbon atom with the functional group gets the lowest number. I'll repeat it again. Now suppose this was not there, okay? Suppose, assume there's just H here and not OH. Me numbering from either this side or this side, it doesn't matter. But now there's a functional group. I have to prioritize the functional group. So what I will do, I have to number the carbon atoms in such a way that the carbon atom with the functional group gets the lowest number. Which means what? This carbon atom has the functional group, so I have to start numbering from here. So go 1, 2, and 3. The last step, or the next rule is nothing but look out for unsaturation. I've already told you what unsaturation is. Presence of double or triple bonded. Now in this case, there is absolutely no unsaturation. There is no double or triple bonded, so you don't have to worry about it. So you just can directly name. Now what is the main name for compound having 3 carbon atoms? It is propane, right? For carbon 1 is methane, carbon 2 is ethane, carbon 3 is propane. So this is propane, and you have a functional group, so you have to use a suffix. Now for halo you have different suffixes. For alcohol it is different suffix, for aldehyde it is a different suffix. So basically each of the functional group have different suffix. So for alcohol you will use the suffix called as OL, alcohol, OL, right? So you have to attach this with your root word. So what is the root word? Root word is propane. So what you have to do, you have to remove the E here and then attach OL. So propane all. So this compound name is propanol. Clear? Now, so I think the number of examples you solve, the better idea you will get. Let us take another example. See here. Again, so number of carbon atoms is how many here? 1, 2, 3. So your root word is propane. You're done with the first rule, right? First rule you're satisfied. What is the second rule here? You have to identify the function group. So what is the function group here? It is your chlorine. So what happens here? It becomes chloropropane. Now this will become as a prefix, so you have to use it as chloropropane. There's no unsaturation here, so you don't have to worry about naming the unsaturation. Suppose if there is a double bond and triple bond, then you will have more complicated names for that, like ethene, ethyne. I don't think which is necessary at this level of point. So all you have to know is the root word. You will know by counting the number of carbon atoms. Then you look for the function group and use the suffix or the prefix accordingly and name the compound. So now that we have learned a little bit of nomenclature, let us go to the chemical properties of carbon compounds. So we have a bunch of reactions, that is your combustion, oxidation, addition reaction and substitution reaction. I hope all of you know what these reactions are. Basically, combustion reaction, basically getting heated up and giving out heat and light. Burning, basically. Burning of a compound is called as a combustion. So now your carbon compounds do undergo combustion, giving carbon dioxide, heat and light. So for a simple example, let us take carbon. Now it burns in air to give you carbon dioxide, heat and light. And you have a methane, right? CH4 is methane. Methane also undergo combustion to give you carbon dioxide, water, heat and light. So most of your organic compounds or carbon compounds undergo combustion. Combustion means burning, okay, gives you carbon dioxide, heat and light. Next, oxidation. What is oxidation? Removal of hydrogen element, oxidation. Now oxidation, not a lot of carbon compounds undergo oxidation. There are few of them. So oxidation of alcohols give you carboxylic acid. Addition reaction. So what is addition in general also mean? Addition is basically you're adding something extra to whatever was there before. So your unsaturated hydrocarbons. Now what do I say? What do you mean by unsaturated hydrocarbons? A double or triply bonded compound, hydrocarbons. Hydrocarbons again nothing but organic compounds. Hydrocarbon, organic compounds, nothing but hydrocarbons. So unsaturated hydrocarbons, that is double or triply bonded, in the presence of a nickel or palladium acting as a catalyst, gives you a saturated hydrocarbon. So you have your double, triply bonded compounds getting converted to a single bonded compounds. Now, here nickel and palladium act as a catalyst. Now, what are catalysts? Catalysts are those chemical compounds or chemicals which increase the rate of the reaction. So, what does this do? They act as catalysts, which means what? They increase the rate of the reaction, meaning they increase speed. Like if it is happening at 10 seconds, it will increase to 20 seconds or 30 seconds. That is the role of the catalyst here. So here you're using nickel and palladium as a catalyst, which brings about the conversion of unsaturated hydrocarbons to saturated hydrocarbons at a higher level. Now, they are basically used in hydrogenation of vegetable oil. So we all use vegetable oil. So basically, they are used in the hydrogenation of vegetable oil. What does hydrogenation mean? Something but addition of hydrogen. So this is one of the examples of your addition reaction. Next, substitution reaction. Now, what does substitution reaction mean? Substitution means something is getting removed and something is getting substituted. For example, the very, very classic example is your, chlorination of methane. So this is your methane, right? Chlorination of methane is a very classic example of a substitution reaction where what happens, you have your CH4, correct? You have your CH4. What will happen during substitution reaction? One of the hydrogen gets removed, right? It comes out and gets replaced by your chlorine atom. That's what you can see here. One of the hydrogen is getting replaced. So what will this become? CH3Cl. Now there is one more. This is Cl2. I'm using a chlorine molecule. So you have one hydrogen that's come out. There's one Cl there. So it will form HCl. So you have CH3Cl plus HCl in the presence of a sunlight. So substitution reaction of carbon compounds. A very classic example is your chlorination of methane, which yields CH3Cl, methyl chloride, plus HCl, presence of sunlight. So the substitution reaction is basically removal of one atom, and that same atom is getting substituted or replaced by another atom. In this case, one of the H gets replaced by one chlorine, forming CH3Cl, that is methyl chloride, plus HCl. Okay. Now, these are some of the chemical properties of carbon compounds. Let us now study some of the carbon compounds in specific, which is ethanol and ethanoic acid. Now, ethanol name itself says ethanol. OL means what? It is your alcohol group. So this is basically alcohol group. Now, ethanoic acid. Ethanoic acid. Oic acid, which means what? Which functional group it belongs to? It belongs to your carboxylic acid, correct? So in the name itself, I've told you, we can recognize to what functional group it belongs to by knowing what the suffix has been used. In this case, it's OL, so it is alcohol. Ethanoic acid is oic acid, which means what is a carboxylic acid. So ethanol, it's liquid at room temperature. It is commonly called as alcohol, that's what I told you. It is soluble in water. Whereas your ethanoic acid is commonly called as acetic acid or carboxylic acid. It is used in preservatives. So mainly it is used in preservatives, and the melting point of your ethanoic acid is 290 Kelvin. Now let us look some of the reactions of ethanol and ethanoic acid. Now, your ethanol reacts with sodium. We have a sodium here, okay? It's a sodium metal, right? So your ethanol reacts with sodium to give you sodium ethoxide, okay? Next kind of reaction is heating of ethanol gives, when you heat an ethanol, what happens? Basically, the ethanol undergoes dehydration. What does dehydration mean? Basically, loss of a water molecule. So when you heat an ethanol, what happens? The dehydration of ethanol takes place, and then you get a unsaturated hydrocarbon, which is the ethene. Now, ethene means what? It is a double bond. When I say ene, it is an alkene group or the double bonded. When I say ine, it will be an alkyne group, which is a triply bonded. Now, what happens when you heat ethanol? The ethanol undergoes dehydration, forming your alkene or ethene. Okay, so dehydration is but removal of a water molecule. Next, ethanoic acid reaction. Now, esterification. What is esterification? Basically, forming of esters. Now, esters are also a class of organic compounds. So, basically, esterification is but the formation of an ester. So, when ethanoic acid reacts with ethanol in the presence of an acid catalyst. Now, as I said, the catalysts are those which increase the rate of the reaction. Now, here I am being very specific and saying it is an acid catalyst, which means what? The catalyst used here is acidic in nature. So, when we use acid catalyst, ethanoic acid and ethanol react to each other to give you ester. Now, the next kind of reaction of your ethanoic acid is reaction with a base. So, I have taken sodium hydroxide as a base. You know what a base is. So, here sodium hydroxide is a base. What happens when ethanoic acid reacts with the base? It reacts with the base to give you a salt. So, whenever an acid and a base react to each other, they give you a salt, correct? So, when your ethanoic acid reacts with a base, it gives you salt. So, these are some of the important reactions of ethanol, ethanoic acid, and some of the characters of or some of the properties of ethanol, ethanoic acid. So when it comes to your exam point of view, esterification is kind of important. Okay, they may ask you to write what is esterification and write the reaction, and also know the properties of ethanol and ethanoic acid, and also make sure you are practicing the reactions of all of these reactions. And definitely one question for sure will be on the nomenclature or the naming of the organic compound.